Hey everyone, and welcome back to our flipped chemistry classroom. And we are talking tonight about chemical reactions and the equations that describe them. So we've learned how to write a skeleton equation, how to write an equation that's unbalanced from a description of the chemical reaction. And now we're going to jump in and we're going to talk about balancing equations. So why do we need to balance an equation? So if we take this example, we have our balloon and it's filled with hydrogen, and all around our balloon we have air, which of course has lots of oxygen in it. And so when we add a spark, that balloon is going to explode. We're going to have hydrogen reacting with oxygen to give us water. So again, we have hydrogen, which we're going to write as H2 because it's one of our diatomic molecules, reacting with oxygen, which again, we're going to write as O2, one of our diatomic molecules, to give us liquid water. What happened to the other oxygen atom? I have two hydrogens, I have two oxygens, and on the product side, I only have one oxygen and two hydrogens. So this equation is not balanced. So our two hydrogen atoms from our hydrogen molecule are going to combine with one of the oxygen atoms from that oxygen molecule to form water. But now we have one leftover oxygen atom, and it's going to find more hydrogen to react with to make a second water molecule. So we're going to write a 2 in front of the water to show that we now have two oxygens, as we did at the beginning, but we're going to need to add in a 2 in front of the hydrogen as well. So now we can see that we start out with 4 atoms of hydrogen and wind up with 4 atoms of hydrogen and begin with 2 atoms of oxygen and end with 2 atoms of oxygen. We have to follow the law of conservation of mass, the law of conservation of matter. We can't just have matter come from nowhere or matter disappear into nowhere. So when we talk about a chemical equation, generally speaking, we're talking about a balanced equation, a balanced skeleton equation. So a balanced equation uses formulas and symbols to describe a reaction. And now, unlike our skeleton equation, it actually indicates how many molecules or moles of each substance are present. We're going to talk later on in the year about what a mole is. For right now, know that it is proportional to the number of molecules. And so our balanced chemical equation is always going to demonstrate the conservation of mass. And when we go to balance a chemical equation, it's really important that we always balance by changing the coefficients of the reactants and the products, never the subscripts. We can't change the subscripts because that would change the identity of the reactants and the products. So the first thing we're going to have to do when we write our equations is make sure that we have neutral compounds. And then once we have the neutral compounds, we can't adjust the subscripts. So this is why I asked you guys when we were learning to write compounds to make sure we use the word neutral, not balance, because you don't want to tangle yourself up thinking, oh, I can balance the equation by changing the subscripts. We cannot balance equations by changing subscripts. We can only balance equations by changing coefficients. We make neutral compounds and then we balance our equation. So let's begin with our skeleton equation. That's where we're always going to begin. So the first thing we're going to do is read the description or the word equation of the reaction. We're then going to write the formulas for each of the reactants. We're going to draw our arrow that we read as yields, and we're going to indicate if there's energy or a catalyst involved. And then we're going to write the formulas for each of the products. So let's take a look at an example. So we have nitric acid dissolved in water reacting with solid sodium carbonate to form liquid water and carbon dioxide gas and sodium nitrate dissolved in water. So we have our equation. We know that nitric acid is HNO3. It says dissolved in water, so we're going to use the little subscript AQ in parentheses. Reacts with solid sodium carbonate, so we're going to write sodium carbonate. Now notice that our sodium carbonate is Na2CO3, and that's because we remember that our carbonate ion has a -2 charge, so I need 2 sodium ions to make this compound neutral. I almost slipped up and said balanced, didn't I? And we're going to say that that is a solid. Now we add our arrow to say yields, and it says sodium nitrate dissolved in water. So here's my sodium nitrate dissolved in water. Now notice I did not bring this 2 over because I don't need 2 sodiums to go with a nitrate. Sodium is +1, nitrate is -1. So this compound is neutral. And carbon dioxide gas, so carbon dioxide gas and liquid water. Oops, I'm missing a plus here. So plus liquid water, and we have a little L to designate that that is liquid water. So is this the whole reaction? Does something need to be added? Is this balanced? Doesn't look balanced to me, because if I look at this, I can see that over here I have 2 sodiums and over here I have only 1. So I know right off the bat, without looking at anything else, that this is not balanced. So I'm going to need to fix that. I also have 1 hydrogen here and 2 hydrogens there. So how are we going to balance an equation? Well, the first thing that I do when I'm balancing an equation is that I'm always going to start with the most complicated molecule. I'm going to count the number of each type of atom on each side of the reaction, and then I'm going to use coefficients, not subscripts, to make sure that they're the same number of each type of atom on both sides. Now recognize that when we put a coefficient in front of a compound, that it applies to the whole compound, not just the first part of the compound, but the whole compound. We cannot change the subscripts. That changes the identity of the compounds. So if we go back to our example equation here, we have nitric acid and sodium carbonate reacting to form sodium nitrate, carbon dioxide gas, and liquid water. So I'm just going to do a quick table here, and I'm going to count up each of my elements. So over here, I have 2 sodiums on the reactant side. I have 1 carbon on the reactant side. I have 3 and 3, so a total of 6 oxygens on the reactant side. I have 1 nitrogen and I have 1 hydrogen. And on the product side, I can see that I have 1 sodium ion, 1 carbon ion, 1 carbon atom, 6 oxygen atoms, 1 nitrogen atom, and 2 hydrogen atoms. So I'm going to begin with the sodium nitrate or the sodium carbonate, because those are the 2 most complicated ones. So I can see that I have 2 sodiums here. So I'm going to go ahead and put a 2 in front of the sodium nitrate. And when I do that, that's going to balance out this sodium, but it's going to make it so that I have 2 nitrate ions. So I'm also going to need to add a 2 in front of the nitric acid. And when I add the 2 in front of the nitric acid, that's going to give me 2 hydrogens to match up with the 2 hydrogens on the product side. And now we can see that we have 9 oxygens on both sides, and we have 2 sodiums on both sides and 2 hydrogens on both sides. So we're all set and our equation is completely balanced. Okay, so next example, we're going to have aluminum metal reacting with liquid bromine to form solid aluminum bromide. So aluminum metal, as a metal, it's going to be a solid unless it's mercury. This is why we learned our few that are liquids. Reacts with liquid bromine. And remember, bromine is one of our diatomics, so we're always going to have the little 2 down there to form. So we have an arrow, solid aluminum bromide. So notice again that because I know that the charge of aluminum is +3 and the charge of bromine is -1, I have 3 bromide ions to go with my 1 aluminum. I did not bring the subscript over from this side. Each time I write a compound, I'm making sure that my compound is neutral. I'm then going to use coefficients to balance the chemical equation, not subscripts. So I can see that the bromine over here has a 2 and over here has a 3. So I know that I'm going to need to put a 3 in front of this bromine and a 2 in front of my aluminum bromide in order to make it so that I have 6 bromine atoms on both sides. And when I do that, I'm going to need a 2 in front of the aluminum on the reactant side. So 2 aluminums on the reactant side, 3 bromines on the reactant side, and 2 aluminum bromide on the product side. Okay, so not too complicated. This should be well within the range of abilities for you guys. But as always, if you have any questions, please let me know. Let's just do a quick summary of what we've talked about today. So an equation describes a reaction. It has to be balanced because it has to follow the law of conservation of mass. It can only be balanced by changing coefficients, not subscripts. And it has special symbols to indicate the state and if a catalyst or energy is required. And we can write a chemical equation to describe any kind of a reaction that exists. All right, I look forward to seeing you in class tomorrow. As always, let me know if you have any questions.